Okay, can we see that? Seems dark in here. Oh, there we go. All right. Um, feels like it's been a long time since I made a video, but it's only been about 2 days. But for today's video, logarithmic differentiation. Okay, so what is that and when do you use it? We could use that for this problem. Find the derivative of x to the x power. All right, we could use that for this problem. Find the derivative of x to the power x squared. All right, maybe you see some similarity between those. And we might think that we could do it like this. Remember this rule right here? If we're talking about logarithmic differentiation, everybody has seen this rule that I'm about to write down. What's the derivative of y equals x to the n power, where that n is a constant. All right. That is not like this problem. It has a superficial resemblance to this rule that everybody knows, but it's not how you do this problem. Well, why is that? Well, because here the power is specified to be a constant. It must be a constant. All right, no other option. It's only for when the power is a constant. We could do, I don't know, y is equal to x to the minus 4 power. We could find the derivative of that because negative 4 is a constant. We could find the derivative of y is equal to x to the pi power because, again, pi is a constant. But here, x is the independent variable, so this rule is not for that problem. Let's establish that. We want to establish the wrong way to do this before we talk about the right way to do it. All right, so say we can get to the point where we agree that, all right, you don't use the rule that you would use for these problems. That's not the way to go with this one. Here's how we proceed with doing this. Okay, since this is not the way to go, okay, here's how we proceed to do this one. We take that initial function and we apply natural log to both sides. All right. I guess we could use any logarithm, but we'll use natural log. Okay. So say we do that. It's saying that if one number is equal to another number, then the logarithm of this one is equal to the logarithm of that one. All right, we can do the same thing to both sides and proceed from there. So I do that. Now, why would I do that? Because that does seem to just make it more complicated than it was when we started. The reason that I would do that is there's this rule that we use quite a bit for logarithms that says if we have the logarithm of something to a power, we have the option to apply that power like as a coefficient of the logarithm, right? So this says natural log of x to the x power, and that would be the same thing as x times natural log of x. Okay. From here, we do something that we have seen somewhere else, okay? This implicitly defines y as a function of x. Notice that it's not explicitly solve for y anymore. So it implicitly defines y as a function of x. So there's this technique that we've seen that we will use here. It's called implicit differentiation. Okay. And no doubt you've seen problems like that before. If we're to this point, that's the technique that you use. All right. So what was that technique? Technique was take the derivative with respect to x of all terms on both sides with whatever rule would be appropriate. So with this particular problem, if I'm on the left-hand side, natural log of y, the derivative with respect to x of that is 1 over y times y prime. Okay. And, all by this method, right? Now, that's another topic. If you've never seen implicit differentiation, then we would have to talk about that before we even begin to think about doing that one. But that's how the method would go for this. And then over here, I'd have to use the product rule, which would look like this. F prime g plus g prime f. All right, so there's the product rule for x times natural log of x. Now, let's do a little bit of cleaning up here. I'm going to leave the left-hand side as 1 over y times y prime. And on the right-hand side, I'll just say, well, that's natural log of x plus 1. Now, the objective in this problem, with whatever route we were taking to get there, is to solve for y prime, and that would be the derivative, and then we would know the derivative, and so on. So there's not much I have to do here to solve for y prime. If I just took the equation and multiply both sides times y, then that would solve for y prime. If I did that, it would cancel 1 over y on the left-hand side. And then over here, you might say something like y times natural log of x plus 1. And you could say, okay, well, there's your derivative. There's y prime. Okay? We'll do one more thing about this, just to incorporate all known information. So this is my derivative, and I've really completed the task of logarithmic differentiation at this point. But I do know what y is. I can put that back in terms of x. From the beginning, we were given that y is x to the x power. So we'll incorporate that, since it is given and known, into our answer for this one. All right, so that will be our derivative. Y prime equals x to the x power times natural log of x plus 1. Okay, so that's as simple as logarithmic differentiation gets. All right, I can't think of one that's easier. I mean, there's nothing else there. X to the x power. Really don't think it gets any simpler, but this will allow you to see it. Let's try that other one. Okay, this has a little bit more to it, but we'll do it the same way. Okay, so we said we'll start by taking the natural logarithm of each side. We do that as a means to an end of doing like so, right? Okay. And then we see that, well, maybe a little commentary. Why do we do this at all? It's that power up there. That's the trouble with this one. We don't have a rule for that. I probably should have said that. But I told you, like, I can't use this rule for this problem. That with this power up here being a variable, in other words, not being a constant, then I don't have a rule for that. And so we need a way to move it so that it's not there anymore. And introducing this logarithm allows us to move it. I should have said that. But all right, I said it here. Yes, I introduced the logarithm. That allows me to move this power. And now do I have a rule for this? The product rule. Now I've got a rule for it. So here I don't have a rule for it. I do that. Now I do. Okay? So, all right, I'll find the derivative with respect to x of this. That will be on the left-hand side. 1 over y times y prime. Okay? And on the right-hand side, with the product rule, 2x natural log of x plus 1 over x times x squared. That's just the product rule. That's the derivative by the product rule of x squared times natural log of x. Okay, so there we go. Let's do a little cleaning up. Let's do 2 steps at once. I'll simplify over here, and I'll multiply both sides by y. I multiply both sides by y so that I can solve for y prime and have an answer for my derivative. And I'll simplify over here just because that's what we do. We don't write 1 over x times x squared. We just write x like that. Okay. So anyway, now we are kind of to a familiar point then in our process. What I'll do a little bit different than the last one with the aim of simplifying is I'll also factor out this common factor of x. Okay, so can we agree with that? The y was already there as a factor. I factored out an x. I always can check. I'll multiply it back through, and I get 2x natural log of x plus x. All right, I get this though. But also, do we know what y is? Can we incorporate some information there that we know? Yeah, y is x to the power x squared. So let's put a note here that, yeah, that's going to be this at some point, okay? But look at it. Look how it's going to read. It's going to say x to the power x squared times x. Now, when we do this, when we say, well, I got an x to the power x squared, and I'm multiplying it times x, that's x to the first power, we'll be multiplying like bases. And whenever you, in algebra, when you multiply like bases, you add the exponents, right? So like what I'm going to be having right there is this or this. Okay, so that is going to be x to the power x squared plus 1. So let's write our answer like this. Y prime is x to the power x squared plus 1. All right. Times 2 natural log of x plus 1. That will be our final answer.